We're going to take a look at how to solve for y prime or dy dx using implicit differentiation. We're also going to take a look at how to use implicit differentiation to solve for d2y dx squared or y double prime. So to solve for y prime, the function or equation that we're going to consider is 2x squared y plus 5xy to the power of 4 minus 2x is equal to, and here I put 0, but this should be a 5. So let me go ahead and change that to a 5. So 2x squared y plus 5xy to the power 4 minus 2x is equal to 5. Our first step is to differentiate both sides of this equation with respect to x. So if we take the first derivative of this equation with respect to x, we're going to have d dx of 2x squared y plus 5xy to the power 4 minus 2x is equal to d dx of 5. So the derivative of 5, since it's a constant, is just 0. So we just need to worry about taking the derivative here. Now, this first part here is going to be a product rule. We have x squared times y. So that's going to come out to be 4x times y plus 2x squared times y prime. Okay, so the derivative of 2x squared is 4x. You multiply it by y, plus the original 2x squared times the derivative of y, which is just y prime. And then we do the same thing over here. So if we take the derivative here, we're going to get 5 times y to the power 4 plus, let's see here, we're going to have 5x times 4 times y to the power 3 times y prime. Okay, because we had to apply the chain rule, right? After we're taking the derivative of y to the power 4, it becomes 4y to the power 3 times y prime. And now we take the derivative of a minus 2x, which just gives us minus 2. And all of this is equal to 0. So let's see here. We can go ahead and combine all the terms with y prime involved. So that'll be 2x squared y prime. Let's highlight this here. 2x squared y prime. And then this term here, 5x times 4y cubed times y prime. So we're going to have 2x squared y prime, let's see, plus 5x. Well, if we multiply the 5 and the 20, we have 20. I'm sorry, the 5 and the 4, we get a 20. So we're going to have plus 20 times x y to the power 3 y prime, and then plus the rest of the other terms. So that's going to be plus 4xy, and let's see, we have a plus 5y to the power 4 here, and then a minus 2. So minus 2, that's going to be equal to 0. And let's go ahead and finish it up here. We can factor out the y prime, and we would have y prime times 2x squared plus 20x is going to be equal to all of this term transposed over here. So that's going to be a minus 4xy plus 5y to the power 4 minus 2. And then we simply divide through by 2x squared plus 20x to get y prime is equal to minus 4xy plus 5y to the power 4 minus 2. And we're going to have all of this, let's see here. All right, we're going to have all of this divided by 2x squared plus 20x. Okay, and this is our solution for y prime. Let's see. Okay, so now let's go ahead and try to solve for this problem here. And here we're going to be using implicit differentiation to find the second derivative of y. So we're looking for y double prime. So we do the same thing that we did here to find y prime first. And then after we find y prime, we're going to differentiate again to solve for y double prime. So let's go ahead and do that. So if we take the derivative of this end here, we're going to get cosine of y plus, and here the derivative of cosine is going to be minus sine, so plus x times minus sine of y. And because of the chain rule, we have a y prime here. So let me go ahead and just rewrite this as cosine of y minus x times sine of y times y prime. So x times sine of y times y prime, and that's going to be equal to y prime on this end here. So we can go ahead and combine these terms, and if we do so, we're going to have y prime plus x times sine of y times y prime, and that's going to be equal to cosine of y. Okay, which means that we can differentiate. If we choose, we can differentiate this equation one more time. And let's see, maybe, actually, let's go ahead and solve for y prime first, and then we're going to differentiate. So y prime times 1 plus x times sine of y is going to be equal to cosine of y. And then we can go ahead and divide through. So y prime is equal to cosine of y divided by 1 plus x times sine of y. Okay, so this is y prime. So we need to find the second derivative here, and we can do so simply by taking the derivative of y prime. So if we do that, let's see, we're going to have y double prime is equal to, now we have to apply the quotient rule over here. So the derivative of this function is going to be the derivative of the top times the bottom minus the derivative of the bottom times the top divided by the denominator squared. So that's going to be the derivative of cosine of y, which is minus sine of y. And then, of course, because of chain rule, we have y prime. And all of this times the denominator. So that's 1 plus x sine of y. And then minus cosine of y times the derivative of the bottom. So this is actually going to be a little bit long, but it's going to be sine of y, and then let's see, plus x times cosine of y times y prime. See if we can fit this here. And let's bring this down. And then all of this is going to be divided by the denominator squared. So that's 1 plus x times sine of y all squared. Okay, so if you notice, we have the y primes in here. The y primes are involved in this equation. Sometimes if you choose, if the y prime is simple enough, then you can simply substitute its value into this equation so that your second derivative is only going to be in terms of x and y, right? No y primes involved. So if you choose, you can replace all the y primes with cosine of y over 1 plus x sine of y. But I wouldn't do so because this might make it look a little bit more complicated. Okay, so this is our second derivative here.